as well. How much will the fourth student get?
75.
Exactly.
Wow.
That's what we mean by each student. Each of them is getting the same amount. Now, she has 32 students. Do I want to write down 75 32 times and then add that up?
Okay.
No, no. Gabrielle, one thing, mathematicians like to be what we call efficient. Oh, no, I am not adding 75 32 times. 32 times. What am I going to do?
75
Times, exactly. I'm not going to add it 32 times. I'm going to multiply the 75 pieces of paper by 32 students. That's much more efficient than adding all of these up 32 numbers. Boy, we'd be here for a long time.
We would.
So let's do that multiplication. And the key words that I'm talking about, each means everyone's getting the same amount, and times tells us to multiply. So here we go. We're going to multiply the 2 times the 75, and then the 3 in the tens place times 75, and put those two partial products together. 2 times 5 is?
Huh?
2 times 5.
2 times 5.
10.
Put down the 0. Let's regroup the 1, or the 110. 2 times 7 is?
2 times 7 is
7 plus 7.
14.
Plus 1 more is? 14 plus the 1. We have to carry the one we carried or regrouped. We have to add that in there. 14 plus 1.
Huh?
All right, you got to listen and stop saying huh, okay? Because I think you're hearing me now. 14 plus 1 more is 15. Okay? Well, now we're going to go to the next number, the 3. Because the 3 is in the tens place, we're really multiplying by 30. So we're going to put a placeholder here. What's 3 times 5?
15.
Put down the 5, and here we're going to regroup our same one again. What's 3 times 7? 7 plus 7 plus 7.
21.
And 1 more, 21 plus 1.
Huh? 21 times 1?
Plus 1. Add the 1 more that we regrouped. You have to add that in. So
22?
22. Now we have 2 partial products that we're going to add together. Can you see my numbers?
Huh?
Can you see the numbers on your screen?
How much is 0 plus 0, Gabrielle?
0.
And 5 plus 5?
10.
We're going to put down the 0 and remember to add that 1 in the next column. 2 plus 1 plus 1.
2 plus 1 plus 1?
Yes.
4.
And then we have 2 in the thousands place with no other number, so we're going to bring that 2 down. Because we have 4 digits, 1, 2, 3, I'll put a comma. Can you read me the product?
2,400.
And what does that represent? 2,400 what?
What was she giving out?
What was the teacher giving to each student? It's not 2,400 students, right?
2,400 pieces of paper.
You got it.
All right, there you go.
Very good job. Excellent. So, Mr. Johnson wrote your name down. We're going to put that in our treasure chest. Since
All right,
it's
we
folded.
have it.
We want to remind Gabrielle and all of our callers out there that it's very important, especially when you get in towards the end of 3rd grade, but by 4th grade, you need to be a master of the basic facts. So make sure you're practicing those multiplication facts, because once you start fractions in 4th and 5th grade, this is going to weigh you down if you don't know your multiplication facts. So learn those facts.
Well, thank you for calling, Gabrielle. Let's open up the lines and see if we have someone else waiting for us. Hello, who is this? And welcome to Count on Us.
Hello.
Hey.
Zion Jones.
Say your first name again.
Zion.
Zion.
Zion, yes.
Okay.
Zion Jones. How are you,
Zion
Zion?
Jones. What's going on, Zion? What school do you attend?
Melwood Elementary.
You're at Melwood. Okay. So what grade are you in?
What
You
grade?
said grade?
Yeah, what grade are you in?
3rd.
3rd grade. I was just at Melwood and working with a 3rd grade class on Monday. Was you in my class?
Huh?
Were you in the class that I was teaching?
What What's your name, Mr. Johnson?
Oh, wow, there we go, Mr. Johnson. Hi, Zion. How are you, sir? Now I remember your face. How are you?
Good. I was in Miss Cole's class.
All right, I'm ready to go with you, Zion. How can I help you? What's your homework?
I'm the same thing we worked on.
The same thing we worked on. Okay.
But you know what?
All right.
Miss Sternberg wasn't there. I don't know what you worked on, so you have to tell us.
Okay, what were we working on, Zion?
Area and perimeter.
Oh,
Area and
nice.
perimeter. Okay,
That's
so
great.
go ahead, shoot the question to me. Let me hear what you're working on.
Find the perimeter of each figure. The length is 10 centimeters long and the width is 4 centimeters.
Okay.
We happen to have centimeter grid paper.
All right. All right, so it says the length is 10, right?
Yes.
So I'm going to start anywhere and I'm going to count 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it says the width is 4, right?
Yes.
Okay. 1, 2, 3, 4. So now I'm going to connect those two lines together. And now I have this shape here. What kind of shape is that, Zion?
Yes.
What kind of shape is that?
It's a rectangle.
It's a rectangle. Excellent job.
And just because I don't want to count again, and I want to remember what you said, I heard you say you did 10 here and centimeters, so I'll put my label, and you said 4 here, centimeters.
Excellent job. Thank you so much, Ms. Sternberg. So now, Zion,
Yes.
it says it wants to find the area. So would the area be from me going from here, going around the outside of this shape?
It says you got to find the perimeter.
Oh, the perimeter. So we're finding the perimeter. So is the perimeter the inside of this shape or the outside of this shape?
The outside.
The outside of this shape.
Around the rim.
So if we're going around this shape, what way would be better for us to count all the way around this figure? What do you think, Zion?
Excuse me?
What's the best way that I can do to get from one end of this corner and go all the way around this shape and come right back? You just told me that was the perimeter, the outside. So one way I can do that is by doing what? What do you think?
You could count.
I could count. So if we start to count, we'll start here and go, how many? Count for me.
1, 2, 3, 4, 5.
Keep going.
6, 7, 8, 9.
Keep 11, 12, 13, 14,
All
15,
the way
16,
around.
17,
You'd have to
18,
count if
19,
you're
20,
counting.
1, 2, 3, 4, 5, 6, 7, 8. So that's one way we could do it. But if this side is 10, if one side, the length is 10, there has to be another side. How much do you think that other side, right on the opposite side of it, would be? If one side is 10,
The other side has to be 10.
yeah, the other side has to be what?
10, because it's not like one of the sides is shrunk in. That will make a rectangle a triangle.
So you have, so let me talk to you, Zion. So are you saying your shape is a rectangle, or are you saying that it's a triangle?
It's a rectangle, but say you make the other side 9, that would be kind of triangle-ish.
Well, why would it be 9? You just told me that the length was 10 and the width was 4, right?
Yeah, that was an example, though.
Okay, so what's your problem asking you?
Find the perimeter.
Find the perimeter, and that's what we're doing. So if L is 10, that means the length. So if this length is 10, then that means this length also has to be 10.
That's a rule or a definition that we always have to follow. If it's a rectangle, whatever one side is, the other side that's opposite, it has to be the same if it's a rectangle.
Okay, you understand what Ms. Sternberg just said?
Yes.
So if this is 10, this side has to be 10. So if this is 4, what should the other side opposite of 4 be?
4.
4.
Exactly.
Excellent job. So one way that you told me we could find was to actually start at a corner and count all the way around, but we were just talking about mathematicians being efficient. So instead of counting all the way around, if I know that this side is 10, this side is 10, this side is 4, and this side is 4, how could I solve this? What operation would you use, Zion, to solve this?
I would use...
Now remember, we have addition, subtraction, multiplication, and division. Which operation would you use?
I would use addition.
And so would I. So I'm going to put 10 plus 10 plus 4 plus 4. And let's add that up. What is 10 plus 10?
28.
Oh, man, all of it together is 28, and I got to put my centimeters to let me know exactly what I'm doing. Okay? Now, besides adding those four numbers up, what could be another way that I can solve this besides adding 10 and 10 and 4 and 4? What's another way I can do it?
Multiplication,
Okay.
because multiplication is the same as math. It's just repeated math.
Repeated, not math, but repeated what? What were we doing at first? What's that A word we were doing at first?
We were using addition.
Addition. So multiplication is repeated what?
Addition.
Excellent job. So now you're looking at your screen, you see what Ms. Sternberg did? She said, okay, there are two sides that equal 10. So 10 times 2 is 20. There are two sides that equal 4. So 4 times 2 is 8. So 20 centimeters plus 8 centimeters gives us what, of course? 28 centimeters.
And what's awesome about that, Zion, is you can see 3 different strategies using the model and counting, addition, and multiplication all get you to the same place. Math is awesome, isn't it?
It's wonderful. How about you, Zion? You good?
Yes.
Okay, so Ms. Sternberg wrote your name down. I'm opening up the treasure chest. She's putting your name. So you make sure you keep watching and hope that we'll pull your name at the end. It's nice seeing you and hearing from you. I'm going to see you again tomorrow, all right?
Yes.
All right, and
right.
we're moving on to our next caller, who I think is Dizon. Hi, this is Count on Us. What's your name?
Dejan?
Dejan. And you're from Robert Gray?
Yes.
What grade are you in, sir?
6.
6th grade. And what problem can we help you with?
I have a ratios problem.
A ratio.
Ratio.
So let's see if we can help you with
Ratio
that.
problem.
What numbers are you dealing with, and what's the problem?
It says there are 22 events at an outdoor track and field meet. There, the ratio of track events to field events is 8:3. How many events of the track events are?
Oh, okay. So there are track events and field events.
Yes.
And the ratio is 8 colon, which we usually say is 2, 8 to 3, because you said 8 colon 3 from track to field.
Yes.
Okay,
Okay.
so 8 to 3, which means for every 8 field events, there are only 3 track, or for every 3 field events, there are 8 track events. Okay?
Okay.
So let's find out, first of all, if we just use these numbers. How much is 8 plus 3?
8 plus 3,
Yes,
11.
11. So the first ratio, 8 to 3, gives us 11 events. How many events are there total?
11.
What's the... No. Total events you told me at the whole event.
22.
22. Do you see a relationship from 11 to 22?
Could you say that again?
What's the relationship from 11 to 22? How do you see 11? Let's come over here. 11 to 22. How do we get from 11 to 22? What do we have to do to those numbers?
Simplify.
Not simplify, but when we get from 11, what do we have to do to 11 to make it 22?
Multiply.
By what?
1.
1 times 11 is only 11.
Multiply by 2.
By 2, which is another word for doubling. So if we take that 11, multiply it times 2, we get to 22, right?
Yes.
So let's use that same multiplication and multiply these numbers times 2. Okay? So 8 to 3, if we multiply 8 times 2, what do we get?
8 times 2.
Yep.
8 times
8 plus 8. 8 times 2.
16.
16. What's 3 times 2?
3 times 2 is 6.
Is 6. How much is 16 plus 6?
Could you say that again?
How much is the 16 track events? We multiply track times 2, field times 2. How much is 16 plus 6?
22.
22. So by doubling the track and field events, we end up with our 22 events. So the ratio is keeping things evenly in proportion, okay? So
Okay.
8 to 3, if we write 8 to 3 equals 11. That's the same as what to what equals 22. And we saw that we had to double them. So 8 doubled was 16, and 3 doubled was 6. So 8 to 3 is a ratio that we can compare to 16 to 6. Does that make sense?
Yes.
Okay. And you mentioned the word simplify, because ratios, if we look at the relationship when we're making them in proportion to each other, 8/16 is simplified as
8.
1/2, 1/2, 1/2.
Yes.
They can all be simplified to 1/2, so we're keeping them all at the same values. We're keeping them at the same values. But 8 to 3 is, for the 22 events, would be 16 to 6. Do you have another way that you would like to show that one?
I was going to cross product, so.
Okay. Oh, that, yeah, so
Yeah.
that won't work. Okay. But we can rewrite them. All right, but are you seeing, Dejan, how we got from 22 events? When you gave us the numbers for 11, we saw that to double them, we got to our total events, which meant we had to double the track and double the field. Okay?
Okay.
Excellent.
So, Dejan, your name is being folded. It's going into our treasure chest. All right?
Okay.
So you keep watching. Hopefully we'll pull your name. Uh-oh, we on fire today. It's a lot of calls
All right,
there.
let's get to the next
let's go. Hello, welcome to Count on Us. Who is this?
Emmanuel.
Emmanuel?
Emmanuel.
Mr. Martin.
Yes.
All right. And you're calling from Melwood?
Yes.
What grade are you in?
5th grade.
5th grade. All
Are you in
right.
that class also?
No, I skipped
Just
5th.
there, you
I'm on
skipped
5th on Tuesday,
All
so
right.
I might see Emmanuel on Tuesday.
Cool.
So, Emmanuel, what's going on with your homework?
Say that again, please.
Why are you calling? What's going on? How can I help you?
Oh, I'm having trouble with dividing big numbers.
Dividing big numbers. Okay, let's see what you call a big number.
100,000 divided by 250.
Now, is this something that you're doing in class? Because we don't typically ask you to do that type of division. We do use tools for that. What kind of tool would you use to divide a big number like that?
No, I'm just trying to advance myself.
Oh,
Okay,
he said,
advance
I'm trying to
himself.
advance
I like
myself.
that.
I like that.
And what kind of tool would you use, though, to solve a problem like this? What's
I don't really know.
technology? What kind of tool would you use? When we have big numbers, we usually use calculators for those.
I do.
Right? Me
I
too.
do. I use
But
a
what
calculator.
was your first number? Was it 1,000 or 100,000?
100,000.
100,000. That's good. No.
1, 2, 3. All right.
One more. You're right.
There we go.
All right.
All right, so you got this number, 100,000 divided by 250. So the first thing is I want to make this number a little bit easier for me, for myself, because I know that I can't give 250 people 100,000 apiece. So I want to make this little number a little easier for me. So I'm trying to figure out, if I cover up this 0 here and I cover up this 0 here, now I'm dealing with 25 and I'm dealing with a 1 and a bunch of numbers here. Is it possible for 25 to be given out within this 100?
Yes.
Yeah, it is. How many times could that 25 be given up into that 100?
4.
4. So we know we're going to deal with 4 somewhere, right? So 25 times 4 is what?
100.
100. Now, how many more zeros must I have in order to get to 100,000? I got 2 zeros here. How many zeros are in 100,000?
5.
There are 5. So how many more zeros do I need to get here?
3.
3. So if I go with these 3 here, that will bring me here. So then all I need to do is on top, put 3, and then we have 4,000. Now we can always check that by multiplying. 4,000 times 250. 1, 2, 3, 4, and then 25 will give me 100, and then we have our answer. You pretty good?
Yes.
All right. Good job, Emmanuel. We're glad to hear that you're bettering yourself. Doing Challenge 24 helps to better yourself as well, so we hope that you'll work on those as well as our other students. Emmanuel's name is going into our Count on Us treasure chest. We're going to take one more caller before our break. Our next caller, I think, is Cameron. Is that Cameron? Is that right? Hi, this is Count on Us. Who's on the line?
Yes.
Cameron. And you go to what school? I think Cameron just disappeared.
Don't hang up, Cameron.
Call back at least, Cameron. We'll take our next caller. Hi, this is Count on Us. Who's on the line? Is this Abigail?
Yes.
Hi, Abigail. We lost Cameron, but we're
Oh.
glad you were hanging on the line and we could bring you on. Abigail, what school do you go to?
Ridgecrest Elementary.
And what grade are you in?
4th.
Fourth grade. And it seems to
Fourth.
me...
Fourth.
Fourth, yep. And it seems...
grade.
Fourth
Fourth grade. That's what we said, fourth grade.
Fourth.
And it seems to me that fourth graders, a lot of you are working on multiplication problems. What are you working on, Abigail?
Multiplication.
Yeah,
There we go,
multiplication. And as I
multiplication.
stressed to our other caller that was fourth grade earlier, I hope you know your basic facts because you're not really doing basic facts in fourth grade with multiplication. You're doing bigger numbers. So let's hear what we can help you with.
75 times 50 using a multiplication model.
75 times what?
50.
50. And we had a very similar problem earlier. 75, we were multiplying
32.
times 32. So we're multiplying that 75 again times a two-digit number. And when you say using a multiplication model, what does your teacher use when she does multiplication models?
She writes the numbers in expanded form.
Oh, okay. So let's make sure we do that. 75, when we expand it out and show the expanded notation, what does 75 equal?
70 plus 5.
Exactly, 70 plus 5. And then when we expand 50, that one's kind of easy. We have what? How many
40
tens?
plus 10.
50. And we have how many ones?
0.
0 ones. Okay, so what we want to do is we're going to end up saying, just like here, we're going to say 0 times the 5 and 0 times the 70. And what's 0 times anything?
0.
0. So we're just going to have a 0. I'm going to put it over here for us. So really what we're doing is multiplying the 5 in the 50 place times the 5 and the 5 times the 70 and then counting all those zeros up. So let's see. How much is 50 times 5? And you can just do 5 times 5 and add a 0. How much is 5 times 5?
25.
25. And we have to remember it's not really 5, it's 50, so let's add that 0 back in, okay?
250.
Exactly,
All right.
250. And now we're going to do 50 times 70.
5 times 7.
Basic fact, 5 times 7.
35.
And how many zeros?
1.
Nope. How many zeros do you have? Because you have 50 and 70. So you have 1 0 in the 50 and 1 0 in the 70. So how many?
2.
2. So we have the 35, and we want to make sure we don't write the 35 under the 25. We want to make sure, because we have 4 digits, 2 zeros, 1, 2, and the 35, that we write it like this. Okay? So 50 times 5 is this one, 50 times 70 is this one. These two would be zeros. And then when we add them all together, and we know adding the zeros isn't going to change it, let's add these partial products. 0 plus 0 is?
0.
0 plus 5 is?
5.
2 plus 5 is?
7.
And 3 plus 0 is?
3.
3. Put our comma in, and when you do the model where you map out the expanded notation, because we had a 0 here, we had 2 zeros here, but we would have 4 different numbers that we add together, and we would add 2 here, and then we'd have to do another addition to get the final product, okay? But because we had zeros here, we only have 2. If we did this one, we'd have the 0 here. 5 times 5 is 25. 5, and carry the 2. 5 times 5 is 35, plus 2 is 37. So we're getting the same answer whether you do it expanding it out or do it the shorter way. Sometimes your teachers want you to expand it out so you can see all the partial products and then work your way into the more fluid way of doing the multiplication and the more efficient way of using the shorter version. But you did a great job, Abigail. Mr. Johnson wrote your name down.
I have it. It's going into the box.
And this seems like a great place to
Take a break.
take a break.
Take a break.
So we're going to go out for a break. We're going to put our Challenge 24 numbers back up for you to look at as we're going out. We want to remind you that the email corner comes on where we have students solving problems for other students. So make sure you watch that, the public service announcements, and we'll be right back.
Hi, I'm Cameron from Samuel Ogle Middle School. Today's email question is from Nicole at Benjamin Tasker. Nicole says, my problem is 98 hundredths times 7 3/10. I don't know where to put the decimal after I multiply. Help! Well, Nicole, first you do basic multiplication. You do 8 times 3, which equals 24. You drop your 4 and carry your 2. Next you do 3 times 9, which is 27, plus 2 is 29. You drop your 9 and carry your 2. Next you do 3 times 0, which is 0, plus 2 is 2. Next we move to the ones column. Now we do 7 times 8, which equals 56. You drop your 6 and carry your 5. Next we do 7 times 9. 7 times 9 is 63. Plus 5 is 68. You drop your 8 and carry your 6. Next we do 7 times 0, which equals 0. Plus 6 is 6. So now we add. For a placeholder, we add a 0. 4 plus 0 is 4. 9 plus 6 is 15. Drop your 5, carry your 1. Next we do 8 plus 2. 8 plus 2 is 10, plus 1 is 11. You drop your 1, you carry your 1. Next we do 1 plus 6. 1 plus 6 is 7. Now we look at the problem. We see that a decimal comes before 3 numbers in this problem, which means in the answer you bring the decimal over 3 places. And you get an answer of 7 and 154 thousandths. Well, Nicole, I hope that was helpful. That was the email question of the day, and I'm Cameron Jenkins from Samuel Ogle. Bye.
Soccer. All across America, it's how kids get fit and have fun. Join us. Go to usyouthsoccer.org.
Welcome back to the second half of Count on Us. Ms. Sternberg, Mr. Johnson are happy to be with you. We're flashing up here our Challenge 24. We haven't had anyone do our Challenge 24 yet, so we want you to make sure you have the numbers. So let's show those. And make sure you're writing these down so you can work on them, because some of you are on the line. We have about 5, 6 callers on the line, which means you're waiting your turn patiently, which is great. But hey, make it valuable and productive. Work on one of our Challenge 24s while you are waiting. Our number, 301-772-0080. Give us a call. We're going to go right to some callers right now.
All right. Welcome to Count on Us. Who's on the line? Hello? Anyone there?
I think Cameron was back.
Cameron.
Yep.
Hey, Cameron. Oh, we got you.
We thought we lost you. We weren't happy with that.
Way to call back, Cameron. What grade are you in?
A 5th.
5th grade at Potomac Landing. All right. Am I right?
Yep.
All right. So what's the fraction problem you got going on?
Yes.
Yes.
What is it? Tell us it.
9 2/7 times 2 2/13.
So 9 2/7 times 2 2/13.
Yep.
Okay. Now, is this a problem that you have for homework, or this is something that you made up on your own?
Homework.
Oh, this is homework. Okay. So, one way that we can work on it, and I'm not sure how your teacher is teaching you, is to turn these into improper fractions. You know how to turn those into fractions greater than 1, an improper fraction?
I get confused.
Okay, well, let's go this way. Always remember, start with your denominator and go towards your whole number with multiplication.
Multiply that.
So, what's 9 times 7?
9 times 7 is 63.
63. Excellent job. Now we move this way to our numerator and we deal with addition. What's 63 plus 2?
65.
So now I have 65, and we come back around to our denominator, which is
7.
7. Okay, so you do the next one for me. 13 times...
2 times 13 is 26, plus 2 is 28.
28.
So
Excellent
28 over 13.
Excellent
Oh,
job.
excellent. Doesn't sound
job.
confusing to me. You got
All
that
right.
perfectly.
Now, these are some large numbers. So the first thing we want to look at, Cameron, is can we make these numbers a little smaller? Has your teacher showed you how to make these numbers smaller?
Simplify?
Well, anyway, it's to simplify, and we can cross-simplify because now we see that 7 and 13 have something in common. What do
7 and 28.
7 and 28 have something in common? What is that number that they have in common? What do 7 and 28 both have in common?
7 goes into 28.
Right, so
Yeah,
common factor.
7 can go into 7 how many times?
3. 7 can go into 7 once.
Once, and 7 can go into 28 how many times?
3.
Uh-uh.
Oh, 4.
4. All right. So now we have a little bit better numbers, okay? So 13 and 65 is something I can do to 13 and the 65 to make those numbers smaller? Do you know a factor that can go in? First of all, is 13 a prime or composite number? You know what prime and composite numbers are?
Prime and composite, yes, I do.
Okay, so since this is a prime number, meaning the only way I can get 13 is by saying 1 times 13, I got to figure out, can 13 go into 65 evenly? Is there any number I can multiply
5.
times? 5?
Yes.
So what's 5 times 13?
65.
Okay, so that means 13 can go into 13 1. It can go in there 5 times. Now look at our numbers.
Woo! Now
5
it's more
times
friendly.
4 is how much?
20.
20. Excellent job. And 1 times 1 is how much?
1.
And any number that's over top of 1 is 20 divided by 1?
Oh, 20.
20. So, if I go back to my problem, 9 2/7 times 2 2/13, what does that equal?
That equals 20.
That equals 20.
And in the beginning, I meant to tell you to look at these numbers and see what is the whole number 9 times the whole number 2. What's 9 times 2?
18.
18. So 18 plus a little bit more is very close to 20. And that helps you to know if you're in the ballpark, if you do that before you start, because this was great, because these were hard numbers to simplify. So you reduce them by doing that division. That was excellent.
And I hope some of our other callers was listening how fast you was quoting those multiplication facts, those basic facts. You was just ringing them out.
So, Cameron, we wrote your name down. It's going in our treasure chest. We have lots of names and a couple more to go before the end of the show, so keep watching.
Okay, all right.
All right, so I think we have a return caller on the line. Is this Zion again?
Yes.
Hi, Zion, and we're still working on area and perimeter?
Yes.
All right, so let's get 2 of your homework problems solved.
I actually have 2 questions now.
Are we going to take...
All right, let's get our area perimeter model.
All right.
And tell me what the problem is. Tell me one of them.
A garden has 8 equal sides and it has a perimeter of 56 meters. Circle the question that gives the length in meters of each side.
Oh, okay. So we don't even have to really use our perimeter model, our model for our grid. We have an 8-sided figure, okay? So 8-sided figure, hard to draw. 1, 2, 3, 4, 5, 6, 7, 8. That's pretty good.
Pretty good to me.
All right, we have 8 sides, and the total perimeter is 56. And did it say centimeters? Did it have a label of what that 56 represents?
No.
Read it to me one more time, Zion.
A garden has 8 equal sides and has a perimeter of 56. Circle each question that gives the length in meters of each.
So meters. Okay.
Okay, so you did say meters, so I'm going to put an M there. That represents meters. So if we have 8 equal sides, and that's, I know my figure isn't exactly to scale representing 8 equal sides, but if all of them are 56 total, and there's 8 of them, how can I find out what each side equals?
By counting that 56?
I could count up to 56 by 8. 8 plus 8 plus 8 plus 8. Is that what you're saying?
Yes.
Well, if I put 8 on each of my sides, and I have 8 sides, I'll have 8 times 8. And what does 8 times 8 equal?
8 times 8.
And I'm going to help you with that just so we know. 8 times 8 is actually 64. Do we have 64 meters?
No.
No, so 8's too big. So it's hard to count up because what we would be doing is kind of guessing and checking. 8's a little too big. We could try the next smaller number. Or what we could do is take this 56 and divide it by the 8 equal sides. Okay?
Yes.
So if we divide 56 by 8 equal sides, it will tell us how much each side is. Because remember, we have that keyword, we're saying each, which means multiply. And division is the inverse of multiplication, the opposite computation. So what we want to do is divide, and if you know your basic facts, Zion, how many 8s are there in 56? Or what number times 8, missing number here, equals 56? Do you know your basic facts?
Yes.
What goes here?
56 times 7 equals 8.
Or
You're close, but you're 56 divided by 7
yes.
equals 8. So 8 times 7, we're looking kind of at fact families, 8 times 7 equals the 56, right?
Yeah.
So each of these sides is how big?
Each of the what is how big?
Each side.
Each side is 56.
No,
No.
not each side. The total is 56.
Oh, so each side is 7.
all
7
right.
meters, and there's 8 sides. So if we added up the 7 8 times 7 equals 56. Excellent job, Zion. Great job. We're going to go take our next caller.
Next caller. Hello.
Hello?
Hi. Who is this?
Hi.
What's your name?
Kumba.
Huh?
Kumba.
Kumba.
Am I saying it right, Kumba?
Yes.
Hi, Kumba. What grade are you in?
3rd.
You're in 3rd grade over at Melwood?
Yes.
All right. How can I help you?
I have a math problem.
Okay, and I'm ready for it.
A doorway is 6 feet 8 inches high. A woman is 5 feet 2 inches tall. How much space is there between the top head of the doorway?
Okay, so once again, the doorway is 6 feet 8 inches high.
Yes.
6 feet 8
8
inches.
inches high.
Huh?
8 inches high.
8. The number 8.
Yes.
Okay. And then the woman is how tall?
5 feet 2 inches.
5 feet
2 inches.
2 inches tall. And they want to know how much space is left between the doorway.
How much space is there between the top of her head and the top of the doorway?
Wow, I like that problem.
Okay. All right. So, do you know how many inches are in a foot?
Huh?
Do you know how many inches are in a foot?
The what?
A foot. How many inches are in a foot? So, if you had a ruler, an inch ruler.
12.
12. So, we do know how there's 8 inches in each foot. So, it's one way we can convert everything. But in this case, because the numbers are so compatible
Yeah,
with us and they
friendly
fit right
numbers.
on top, since there are 8 inches and she's only 2 inches, I could just basically subtract those. What's 8 take away 2?
6.
6. And because the feet is larger, 6 feet is larger than 5 feet, I can just subtract those. And 6 feet take away 5 feet is
6 inches.
6 feet take away 5. 6 feet take away 5 feet is
1.
1. Now, it just wanted to know how much space was left in between her top of her head and the top of the doorway.
1 feet 6 inches.
1 feet 6 inches.
And I just want to put up my little sketch because sometimes when you draw things out, it helps.
Okay.
So there's my little sketch, and our lady's smiling. And here's the doorway, and it's 6 feet 8 inches. Here's our lady who's 5 feet 2 inches. So we're trying to find this space in here, and you did your subtraction to get 1 foot 6 inches. The only thing I really want to point out, so I hope our students know this, is that you wrote feet and inches. I hope you know our abbreviation symbols for feet and inches. 1 line means foot, 2 little lines mean inches. So that's something else to remember that you can start using. Symbols help us in mathematics as well.
Did you see that, Kumba? Did you see what Ms. Sternberg drew for you?
We might have lost. Oh, Kuma, you still there?
Yes.
All right, and we're putting your name in our treasure chest.
All right.
Keep watching
It's
for
getting
just a
full
couple more
today.
minutes to
All
see
right.
what happens.
It's getting full.
All right, well, next caller we have is Ava. Hi, Ava.
Hi.
This is Count on Us. Tell us what school you go to and what grade you are in.
I'm in 2nd grade and I go to Melwood Elementary.
Oh, wow.
Melwood is representing
is the
today.
school
Oh, they
of the
represent
day.
today. All right.
Awesome, Melwood. Great job. Awesome, Ava. So, Ava, what problem can we help you with? 2nd grade. What are you working on?
I'm working on I need help on breaking out the numbers to add
Okay. Tell me what the numbers are.
70 and 90.
70. I don't know if I keep switching my pens. I have one good one and one not so good one. Here we go. 70 plus 90. Okay. Do you know your basic facts, how to add your numbers?
Can you say that again?
Do you know how to add numbers? If I said
Yes.
to you, can you tell me how much is 7 plus 9?
18.
No.
That's close. Okay? And you know what sometimes we do? 9 is 1 more than 10. I mean, 1 less than 10, right?
Right.
If I make this a 10 and I take 1 away from this and make this a 6, I added 1 and I took away 1, and now look how easy these numbers are. How much is 10 plus 6 more?
16.
16.
All right, there we
so
go.
sometimes we can make the number equal 10, but if we added 1 from one number, we have to take away 1 from the other number and know what we did, okay? So here we have 16. If 9 plus 7 is 16, when we come over here to 70 plus 90, we still have 9 plus 7 is 16, but we just have to remember to put the 0 because 0 plus 0 is how much?
0.
Zero.
So our zeros in our ones place equal 0, and this looks like 9 plus 7, even though it's 90, 9 tens and 7 tens, it still equals 16 tens. And what's our final sum? What's the sum? What do these equal?
160.
Exactly,
All right.
160. So with no zeros, it equals 16. With 1 0, it equals 160. And let me show you one more quick thing, Ava. Because now you're so good at this, watch. If I put this at 700 and 900, if you know what 9 plus 6 equals, 9 plus 7, how much is 9 plus 7?
16.
16. So you have to remember that, because now 0 plus 0 is 0, 0 plus 0 plus 0, and 9 plus 7 is 16. Now you can even add in the hundreds, because all we're doing is adding those zeros. Ava, great job. We're going to try and get to one more caller, but you put her name in there,
I
right?
did. I put her name in.
Awesome, Ava.
All right. Welcome to Count on Us. And who's calling?
Hello?
Hello. I can hear a little echo. Turn your
Echo.
TV down for me and say your name.
Ariana.
Ariana. All right. What grade are you in?
6.
6th grade, Cherokee Lane.
Yes.
All right. So, what's your homework?
We were working on integers.
Integers. Okay. So, what did it ask you to do?
There are two temperatures, negative 258 degrees Celsius and negative 210 degrees Celsius.
Okay. Negative 200 and negative 210.
Negative 258.
And
Ne-
210, yes.
Okay. Negative 258 and negative 210. Okay. I got that part. Keep going.
And it wants to know which is warmer.
Which one is warmer?
Warmer.
Okay. So here's an idea. So when you're looking at 0, which way are negative numbers, integers? Which way are the negative numbers from 0?
Left or right? Or up or down?
Yeah. So going away from 0, which way would negative numbers be on this number line? If this is 0.
To the left.
To the left. So we know that these numbers over here are negative. And we know that since that is negative, that these numbers must be positive. So the further I get away from 0, the colder it must be. You agree?
Yes.
So which one is closer to 0? Negative 258 or negative 210?
Negative 210.
So if they ask you which one is warmer between negative 210 and negative 258, you're going to tell them what?
Negative 210.
Excellent job.
And what you can also do, Ariana, we went to the left and right with these numbers on the number line. You can also turn it this way, and the negative numbers go down below, and the positive numbers, and the positive stays right there, go above the 0, okay? Because that's how we look at it on a thermometer. Above and below, as the temperature rises, it gets warmer. So the 210 would be here and the 258 would be below it. You get the same answer no matter which way you move when you're working with integers, okay?
Okay.
Awesome.
Okay.
I think awesome's my word of the day.
That is.
All right, so
we
I
can get to
think
one more. You
Ariana.
think we can get to one more?
All right, let's try it.
Let's try one more.
it.
Real quick.
One more. We have Leslie on the line. Hi, Leslie. Now, Leslie, I'm hearing myself talk. That's not a good thing. Mute the volume off your TV. Are you there, Leslie?
Yes.
Okay.
All right.
Hi, Leslie. And you go to Templeton? Oh, I'm hearing myself talk, Leslie.
Come
Can
on,
you turn
Leslie.
the TV?
We're
Because
trying to
we're
work
running
with
out
you.
of
We're
time.
running out of time. We're trying to get
before
you
we
in.
run out. Did you turn the TV down?
Okay.
All right. Leslie, what grade are you in?
Fifth.
5th grade?
Yes.
All right, 5th grade at Templeton. And what problem can we help you with? We're going to try and zip through this and get you started on your homework before we run out of time. So tell us, Leslie.
It says the 6 in the 10th place is blank the value of the 6 in the 10th place.
The 6 is in the tens place?
Yes.
Okay. What else do we know? And because you said there's a 6 in the tens place, I automatically put a ones place. Go ahead. Got to tell me some more information.
There's a number that it says.
Leslie, did you say tens or tenths?
With a THS.
Is there a
It says-
TH on the end of the word?
No, it says the 6 in the 10th place is the value of the 6 in the 10th place.
Okay. The 6 in the tens place is the same value as the 6 in the tenths place?
Wow.
And what else is it asking? What's the question? What's the question it's asking us?
It says to find the value.
Of? Because all I'm hearing you say, there's a 6 in the tens place, and then it's the same value as the tenths place. So these are our ones, these are our tens, and these are our tenths. So if this has the same value, I would put a 6 here as well. Okay? But I'm not sure what else you're asking, or the question. Are you reading this off something? A book or a paper?
It's a paper.
And what else does it say? The value of the 6 in the tenths place has the same value as the tenths place.
What's the total value?
What else does it say?
It'll have to be.
That's it.
That's it?
That will have to be.
Well,
60.
yeah, if they're not giving you anything else, we're gonna say a 0 goes here. And maybe that's what they're looking for. We're not 100% sure,
Just
but
to make sure you can put them in the right place.
right. And if you put those two in this place and we have a digit here and they didn't tell you any digit, we're going to put a 0 in place. And we're going to go to our drawing. Did we get
All
Leslie's
right,
name?
Leslie, got
Leslie, you
you.
are the last caller going into this
All
show's
right, we're running out.
treasure
We're gonna
chest.
Go through,
Shaking
shake it up. All right.
I'm pulling one name. I wouldn't be surprised if it's a Melwood name.
Uh-oh, let me see. Let's see. Dejan, I can't remember
I
where
don't remember. I
Dejan
try
was
to write the
calling
schools.
from.
Dejan,
All right.
whatever school you're from, congratulations to you, and thank you to all the rest of our callers who called in to count on us from
Count
the
on
4
us.
o'clock 4 to 5 o'clock version of the show. Remember, Count on Us comes right back on
Right
after
back
a break
on.
from 5 to 6 o'clock. You'll have 2 new hosts that will work through your homework with you, so start making those phone calls now. And for Mr. Johnson and myself, remember, you can always
Count on us. All right. Bye-bye.
Hi, I'm Miss Frank, and I'm here with today's mini lesson on elapsed time. Elapsed time is when we find the difference between the start time and end time of an event, such as a game, a movie, a race. So I'm going to work on one-word problem with you and show you how I would solve it, and hopefully that will help you solve elapsed time problems in the future. So let's take a look at a problem. This problem is about my friend named Melanie. Melanie was going to the movies. She went to a movie that started at 10:30 a.m. So I'm going to go ahead and I'm going to write down the start time. 10:30 a.m. The movie was 3.5 hours, and we want to find out what time the movie finished. So what we're going to do is we're going to start with our start time, and then we're going to count on the hours first. When we're finished counting on the hours, we're going to then switch to counting on the minutes, which is often what I like to do with elapsed time. Start by counting on hours until we can't add on any more hours, and then we switch to minutes. So let's take a look, and we're going to use a clock, and I preset the clock to 10:30 so that we were ready to go. So let's take a look. We're going to start at 10:30, and we're going to add on 3 more hours, and then we'll worry about the minutes later. So we're starting at 10:30. 1 more hour gets us to 11:30. 1 more hour gets us to 12:30. And then our third and final hour brings us to 1:30. So let's go ahead and write that out on our problem, and that way we can see exactly what we just did on the clock. So we were starting at 10:30 a.m., and 1 more hour brought us to 11:30 a.m. So that's our first hour. Then we went from 11:30 a.m. to 12:30 p.m. And that was our second hour. Notice how I went from a.m. and p.m. because we were at 11:30 a.m. So the next hour would actually be 12:30 p.m. So be very careful to look at your a.m. and p.m. when you're working out a problem to see if somewhere in your problem you're switching between a.m. and p.m. Be very careful. We then went from 12:30 p.m. and we added on our third hour, and that brought us to 1:30 p.m. So there, we added on our 3 hours. We then need to go back and add on our half hour. Since an hour is 60 minutes, then a half hour is 30 minutes. So let's go back to our clock and add on 30 minutes. So we are here at 1:30 p.m. So let's count by 5s and add on our 30 minutes. 5, 10, 15, 20, 25. There's our 30 minutes, brings us to 2 o'clock. So let's show that on our problem. and we were at 1:30 p.m. And then our half hour brought us, to 2 o'clock p.m. And that was our 30 minutes. So let's take a look. We added on our 3 hours and 30 minutes, and that brought us to 2 o'clock p.m. So Melanie's movie ended at 2 o'clock p.m. So whenever you're working on elapsed time, remember to start by counting on your hours until you can't add on hours anymore, and then switch to adding on your minutes. And that will hopefully help you find elapsed time in the future. If you don't have a clock at home like I had here, you can always draw one on a piece of paper. Start by drawing a circle. Put your 12, your 6, your 3, and your 9. Put the other hours in between, and then at least you'll have a visual that will hopefully help you add on your hours and your minutes for elapsed time. Thank you so much, and stay tuned for some more Count on Us. Have a great afternoon.
Across America, Service Learning is helping students improve their grades and their communities. Service Learning makes school exciting by connecting the classroom with community service projects.
Before Service Learning, I was just an ordinary student causing mischief during class. After Service Learning started, I got so involved into it, I started paying attention more, picked up my grades.
Okay, very good.
Service Learning absolutely drives academic success.
Working together, students solve real problems, build new skills, and apply their knowledge in a whole new way.
The great thing about Service Learning is it gives you this opportunity to go out into the world and do things hands-on.
Inside the classroom and out, Service Learning opens new doors and brings learning to life. Service Learning can make a difference in your school. Visit Learn and Serve America at learnandserve.gov to find out how.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself.
So the second equation for solve perimeter is?
2 times length plus 2 times width.
And welcome to Count on Us, the second part of the show. I'm Miss Shirey.
And I'm Miss Twitty.
And we're here to help you today with your homework. Again, we're continuing from our first show. We're excited to be on the air with you today. And we have some callers already. But before we get to our callers, let's go over our new challenge for the hour. It's a First in Math Challenge 24 challenge. We have some harder cards today. We have A.
With the numbers 8, 8, 4, 7.
We have B with 23, 5, 7, and 13.
We have C with 21, 13, 21, 24.
And card D, 4, 4, 9, and 3. Write those down. Take a minute to figure those out while you're working on your homework, and we will be happy to hear from you working out those problems. We're going to go right to the phone lines now because I think we have so many callers today.
Okay. First caller, what's your name?
Hello, welcome to Count on Us.
Can you turn your TV down for us? And then just listen to the telephone. Hello, how are you?
Good.
Okay, what's your name and what school are you calling from?
Kyle.
Kyle?
Yes.
Okay, what school are you calling from?
Charles Carroll.
All right, what's your problem?
Negative 1.23 times negative 2.94.
Say that last part again. Negative 1.13.
Negative 1.23.
23, okay. Times?
9.34. Negative 9.34.
Negative 9.34. Okay. All right. Have you been working on these in class?
Yeah.
Okay. Do you know what step to start with? What did your teacher show you? What steps did your teacher show you? What do you think is the first step?
Multiplying.
Well, okay. Well, first of all, I wrote it out horizontally. So let's write it out vertically. Times 9 and 3,400. Both these numbers are negatives. Okay. All right. So we're going to multiply these two numbers, and they have decimals in them. We're just going to start to multiply it out the regular way. The decimals are not important right now. Okay.
Yeah.
All right. So where are we going to start?
Multiplying 4 and 3.
Good. What's 4 times 3? That's 400ths times 300ths.
Wait, can you repeat that again?
So 4 times 3.
12.
Is 12. So we leave the 2. We're going to regroup the 1. 4 times 2.
8.
Plus 1 more.
9.
Good. And 4 times 1?
4.
4. Good.
Good job.
Okay. Now, I like to go back and erase all my little regrouping marks up there because now we're going to go through this time and multiply again, and I don't want to get confused. Does that make sense?
Okay.
Okay. Now, we're done in the hundredths column, so I like to cross them out. We're done with the 4. We're going to move on to the tenths spot. But if we're moving on, we need a little placeholder. Okay, so let's multiply times this digit now. 3 times 3.
9.
3 times 2.
6.
Good. And 3 times 1.
3.
Excellent. Okay. Now we're done with the tenths column. I like to cross him out. Let's move on to the whole numbers, to the ones column. All right. Let's put down our placeholders. 9 times 3.
27.
27. Good. 9 times 2.
18.
Plus 2 more.
20.
Great. You know your facts. 9 times 1.
9.
Plus 2 more.
11.
Very good. Okay. So now what we need to do is put together all these pieces that we just multiplied out. Okay?
Mm-hmm.
All right. So 2 plus 0 plus 0.
2.
9 plus 9.
18.
Good. 18. Regroup the 1. Now I see 6 and 4 here. I know that quickly makes 10. So 10 plus 7.
10 plus 17.
17 plus the 1 we regrouped.
18.
Good. Regroup the 1. 3 plus 1.
4.
Good. And then these, 1 plus nothing, 1 plus nothing. Okay, now this is the part where we have to go back and look at the decimals. How many places after the decimal do you see up here in the factors?
2.
Well, I see 2 here. 1, 2, but there's more in this number. How many do you see in this number?
2.
2.
Good
Very
job.
good. 1, 2. So we want to look at all the factors and count up how many places after the decimal. 1, 2 up here, and 2 down here, and 2 up here and 2 down here makes how many total?
4.
Good. So we're going to start back here and move our decimal place. 1, 2, 3, 4. Okay? So our decimal place is going to go between the 1 and the 4. Now the other trick to this is you are multiplying two negative numbers. What happens when you multiply two negatives?
The answer becomes a positive.
Very good, very good. It does become a positive. So we can just leave this alone. We don't have to worry about that putting a negative because we know it just turns into a positive. Now, if we use some estimation, we'll find out that our answer looks like it's right. Because if I ignore my decimal places over here, if I just make it a simple problem, it's 1 times 9. What's 1 times 9?
9.
9. And our answer was 11 point something. So that's relatively close, so we're probably right. Okay? Does that help you today?
Yes.
All right. Thank you so much for
Thank
calling.
Okay, good job. I'm going to put your name in our treasure chest.
Great. Thank you for calling. We're going to move on to our next caller. Hello. Welcome to Count on Us.
Hello.
Hello. And who is this?
Roderick Williams.
Roderick Williams. And what school are you from?
Akakik Academy.
Wonderful. And what grade? What grade are you in?
7th.
Okay. And how can we help you today?
The problem in my book says negative 84 equals negative 2 times and negative 3, and the negative 3 is in parentheses, and then it says times, and then it has a blank spot.
Okay. Let's hear this out. So it's, what is it again?
Negative 84.
Negative 84. Okay.
Equals. Negative 2. Times. Negative 3. And the negative 3 is in parentheses.
Like that?
Yeah.
Okay.
And then it has another multiplication symbol. And then it has a line.
Oh, okay. It looks like that.
Yeah.
And you're supposed to figure out what the line is?
Yeah.
Okay. All right, Miss Twitty, you want to help him with that one?
So Roderick, do you know what this equal sign means?
No.
Okay, so that means whatever we have over here has to be the same of what we have over here, okay?
Okay.
So what do we have on this side of our equal sign?
A negative 84.
Very good. So what are we trying to get on this side of our equal sign?
The numbers to equal negative 84.
Okay, the numbers to equal a negative 84. So what would negative 2 times negative 3, what would that give us?
That would give us a positive 6.
A positive 6. Good job. Okay, so now we have a positive 6 times something. Can you think of 6 times something that might give us a negative 84?
6 times something.
That's a hard one.
Yeah. 1 second.
So Roderick, do you think it's going to be more or less than 10?
It is. What is it?
Roderick, do you think it's going to be more or less than 10?
It's going to be more.
How do you know it's going to be more?
Because if it's 6 times 10, then it's going to be 60, and that's not enough.
Okay, good job. So what number do you think it would be?
12.
Okay, what's 12 times 10? I mean, 12 times 6.
2 times 6 is 2 times 6 is 12.
And 6 times 1 is?
Is 6
plus 1 is
7.
Good.
72.
All right, good job. Is that going to help us?
Huh?
Does that get us to 84?
No.
Okay.
So 13.
Okay, what's 6 times 3?
6 times 3 is 18.
And then 6 times 1?
6 times 1 is 6.
Plus 1?
7.
Oh, we're so close, Roderick. So 13 times 6 is 78. So what do you think our next number should be?
14.
All right, let's try it. 14 times 6. What's 6 times 4?
6 times 4 is 24.
Okay, and then 6 times 1?
6 times 1 is 6.
Plus 2.
Plus 2, 8.
Very good. So 14 times 6 equals?
equals 84.
84. So what number do you think should go here in our blank?
14.
14. Now, Roderick, I have one more question. On this side of our equation, what do we have?
Negative 84.
So if we multiplied 6 times 14, what would our answer be?
Negative 14. No. Negative 14.
Well, 6 times 14 would give us
6 times 4, 100. I mean 84.
84. So how do we get a negative 84 on this side?
By having a positive 14.
Okay, so if we have a positive 14, what would we make our 6?
A negative.
Okay, so since they are, since we already knew that our 6 was positive, perhaps we should make our 14 negative.
Yeah.
Okay.
Okay.
Good job. Do you understand?
Yes.
Okay, very nice job. Have you tried our challenge, Roderick?
Yeah, I have numbers, but I didn't get it yet.
Okay, so keep working on that and call us back before the end of the show, okay?
Okay.
All right, we're going to put your name in the treasure chest.
Okay.
Very nice job.
All right, thank you for calling, Roderick. Okay, we're going to go on to our next caller. Hello, welcome to Count on Us. Hello?
Yes.
Hello, friend. Welcome to Count on Us.
Thank you.
And what school are you calling from?
Melwood.
Wonderful.
Melwood.
Melwood. What a great school. And what grade are you in?
3rd.
3rd grade?
Yes.
Okay. And how can we help you today?
5 divided by 10.
5 divided by 10.
Do you have a word problem, or is that your problem?
Say that again, please.
Do you have a word problem, or is your problem 5 divided by 10?
It's a problem 5 divided by 10.
Okay, can you see us on TV?
No, I'm calling from my own phone.
Okay.
So is the 10, would the 10 be inside the division box, or is it going to be outside?
It will be inside.
Inside? Okay. 10 divided by 5. If it's inside, the 10 would be inside the box. Some people call this the garage. They say it looks like a little garage. It's inside there? And the 5 is outside?
Yeah.
Okay,
Yeah.
so 10 divided by 5. Do you know what 10 divided by 5 really means? What are you trying to figure out?
I'm trying to figure out what it equals.
Okay, well, when you're dividing, the 10 is the dividend, and that's the part that we're going to try to share. Did you know division is like sharing?
Yes.
Okay, so we're going to share when we divide, and we have 10 things to share, don't we?
Yes.
Okay, so if I have 10 things to share, and then what the divisor is telling me is how many groups to put them in. So how many groups do we have?
We have 5 groups.
5 groups, okay. So what I'm going to do, I know you said you can't see me, but I'm going to draw 5 groups, and then I'm going to count out and share out 10 things. We can just pretend they're cookies, because I'm getting really hungry, and I shouldn't eat cookies before dinner, but maybe I can eat a few, okay? So if I had 10 cookies to share out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I shared out 10 cookies to 5 different people, do you know how many cookies each person would get?
1.
Well, if they each got 1, then I would only have 5 cookies. But I have 10 cookies.
Ryan, you could think in your head, 5 times what number gets me closest to 10 without going over?
55.
5 times...
How many groups of 5 are in 10?
Huh?
How many groups of 5 are in 10? How many times do you need to count by 5s to get to 10?
You have to count.
Count with me. 5,
5,
10. How many times did we have to count?
2 times.
2 times. That's right. Guess how many cookies are in everybody's group?
2.
2 cookies. That's right. So 5 times 2. I like that strategy Miss Twitty just gave you. 5 times 2 is 10. If you know your multiplication tables, you can divide. It's just going backwards.
All right, thank you, Ryan. We're going to put your name in our treasure chest and keep watching to the end of the show to see if you win a prize, okay?
Okay.
All right.
Great. Thanks for calling, Ryan.
I think we're ready for our next caller. Hello. Welcome to Count on Us.
Hi.
Hi. What's your name?
Mohammed.
Hi, Mohammed. What school are you calling from?
Turning Point Academy.
Okay, and what grade are you in?
5th.
5th grade. Okay, Mohammed, what's your problem?
My problem is water stations will be replaced every 400 meters of a 5-kilometer race. How many water stations are needed? And then it says, hint, 1 kilometer equals 1,000 meters.
Okay, so the problem says, read the problem one more time.
Water stations will be replaced every 400 meters of a 5-kilometer race. How many water stations are needed?
Okay, and what was the hint?
1 kilometer equals 1,000 meters.
Okay, so 1 kilometer equals 1,000 meters. Okay, I think we've got it. Okay, so where should we start?
I think you should start by dividing 5 by 400.
Okay. I want you to take a look, though. What do you notice here? I bet Miss Twitty notices, too. You gave me 2 different pieces of information.
Yeah. It says the M stands for meters and the KM stands for kilometers.
Right, or kilometers or kilometers. Very good. So I would think that we would have to do something with those numbers before we did anything else. What do you think, Miss Twitty?
So what do you think we would have to do with those numbers?
Divide them.
Do you think there's a way we could have the same units?
Think about the clue that they gave you over here. There's a reason why they gave you this little hint over here. How many kilometers or kilometers are we talking about?
5.
5. But we're not talking about kilometers or kilometers over here, are we?
Yeah.
We are? You told me meters.
No.
Right, meters. So how can I change this part into meters? If 1 kilometer is 1,000 meters, how many would 5 be?
Changing it to 5,000.
All right. Good job, Mohammed.
Good.
How did you do that?
I did 5 times 1,000.
Why?
Because it says 1 km equals 1,000 meters, so, and then it says 5 km, so I multiplied the 5 by the 1 and add the 3 zeros.
Very nice job, Mohammed. So now what do we do?
Then you divide it.
What are we going to divide?
400 by 5,000.
Which goes inside?
Huh?
Which goes inside here?
The 5,000.
Okay, so there's 5,000 meters in this race. And every time you get to 400, they're going to put a water station?
Yeah.
Okay. All right. Walk me through this problem. What should I do?
See how many times 4 could go into 5.
Okay, but we have 400, so can 400 go into 5?
Yes.
Oh.
Wait, no. So then you move it over.
Right. Can
So it
400
would be
go
50.
into 50?
No.
Can 400 go into 500?
Yes.
How many times?
Once.
Okay, 1 time. What's 1 times 400?
400.
Good.
Right, Mohammed.
500 minus 400?
100.
Very good. bring down the 0. Okay, let's start again. How many 400s would be in 1,000?
6.
6. That's a little high. 400 is almost close to 500, and I know 500 is half of 1,000. I think 6 is a little high. Well, how many 4s would go into 10?
2.
2.
Good
Let's
job.
try 2. 2 times, now you're very good at the zeros. You already knew to add the zeros. So if I do 2 times 4, what's 2 times 4?
8.
8, and then we just have 2 more zeros. So 2 groups of 400 is 800. So if I have 1,000 minus 800.
200.
Good.
Good job.
Now, the problem is we don't have any more zeros, so we need to put our decimal point. Do you know how to do that?
No. Well, I learned it. Yeah.
Okay, so what happens is this problem is going to have to be divided with a decimal in the quotient. We don't have any more zeros to bring down, but we can put some more on the end and not really change the value. So if I put another 0 here to bring down, now I have 2,000. How many times does 4 go into 20?
Mohammed, how many times? Oh.
4 times what is 20?
6.
4 times what number equals 20?
5.
Good.
Okay.
All right. 5 times 4 is 20, and then I have my 2 zeros. And then look what happens, Mohammed. 2,000 minus 2,000 is 0.
0.
Okay.
So, Mohammed, how many water stations would they need at this race?
12.5.
Well, Mohammed, can you have a 0.5 of a water station?
Huh?
Can you have a half of a water station?
Well, no.
Okay, so how many water stations would they need?
12 5/10.
Well, Mohammed, I don't think we can have half of a water station, so we would need a whole water station.
It'll be 13.
Very good job, Mohammed.
Right.
It would be 13. Very good. So we're going to go ahead and put your name in the treasure chest. Excellent. And then we're going to go to break, and we'll be back in a few moments. So if you're on the phone, don't hang up, and we'll come right back.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
At this moment, across the country, families are packing their bags for a getaway. And no matter where they end up, they'll all be home by dinner. Plan your own at playgolfamerica.com. From finding programs in your area to finding advice from PGA professionals, PlayGolfAmerica.com has a way for you to get away. Visit today for details. PlayGolfAmerica.com, your link to the game.
It's easy, Grandpa. Brush your teeth twice a day. Floss your teeth once a day. That's the way to fight decay, hey, hey. Brush and floss every day, hey, hey. Healthy smiles are the way, hey, hey, hey.
You can keep your smile for a lifetime, even a boomer-saurus like me.
Boomers, you gotta love them.
And welcome back to the second half of Count on Us. I'm Miss Shirey.
And I'm Miss Twitty.
And we're here to help you today with your homework. We have so many callers. We're going to jump right back in and welcome our next caller to the show. Hello. Welcome to Count on Us.
Hello?
Hello.
Hello.
Who is this?
My name is Jonathan.
Hello, Jonathan. It's nice to meet you. What school are you calling from?
Beacon Heights Elementary School.
What a lovely school. And what grade are you in?
4.
Excellent.
4th grade.
And how can we help you today?
I'm trying to do lattice method.
Oh, what a good method. Okay, what problem are you working on?
99 times 44.
Okay, 99 times 44. Okay. All right.
Okay. Jonathan, can you see us?
Yes.
Okay. So do you already have your lattice box drawn?
Yeah.
Okay, so Jonathan, make sure that you mute your television and just listen to the telephone, okay?
Okay.
Okay, so Jonathan, what should we do with our box here?
We should put it in 4 squares.
Okay, so we're going to make 4 squares. And then what?
Then you do 9 times 4.
What do I have to do to my box before I start multiplying?
Draw the lines.
Okay, which way should the lines go?
Top. The top.
Okay, so I'm going to make diagonal lines through all of my boxes, okay?
Okay.
Okay, so now we're ready to multiply. You said 9 times 4?
Yes.
Okay, what's 9 times 4?
It's 28.
Are you sure?
No.
Okay. Do you know what 10 times 4 is?
10 times 10?
No, 10 times 4.
10 times 4 equals 40.
Okay, subtract 9.
41? Oh, no, 31?
Oh, no, that's, you did that correct. That was Miss Twitty's,
subtract 4.
Subtract 4.
4?
Yes, so take 40 and subtract 4.
46?
40 minus 4.
36?
Very good job. So 36. So this box represents our tens place, and this box represents our ones place. So I'm going to write 30.
Yep, I'll help you out.
Thank you.
Whoa, our markers. Let's try
30.
this one. There we go. 36.
6. Okay, Jonathan, what's 9 times 4?
36.
Very good.
Okay.
And then the same thing in this box. 9 times 4.
36.
Okay, and the box on the bottom?
36.
All right, what do we do next?
You add.
Okay, what are we going to add?
For the middle, we are going to add down there.
Okay, so what would we have here?
6.
Okay, good job. And then in this column? 6 plus 6?
15.
Okay, very good. The answer is 15. So Miss Twitty thought 6 plus 6, that's a double. So 6 plus 6 is?
12.
12, and 3 more.
15.
Very nice job. So I'm going to put down the 5, and then I'm going to
Add the 1.
Very good. So 3 plus 3 is?
3 plus 3 equals 6.
Okay, that's a double. And then 6 plus 6?
12.
Very nice. And 1 more?
13.
Okay, so I'll put down the 3 and?
Add the 1.
Okay, and then 3 plus 1?
4.
Okay, so 99 times 44 equals?
4,356.
Very nice job, Jonathan. We're going to go ahead and drop your name in the treasure chest. And have you tried one of our challenges today, Jonathan?
No.
Okay, so I'm going to put the numbers up real quick so you can see, and then jot down the numbers and give us a call back in within the next 20 minutes so you can try one of our challenges, okay?
Okay.
Okay, do you have the numbers?
Yes.
Okay. Thank you for calling, Jonathan. We look forward to hearing from you again.
Okay.
Okay, bye.
We're going to move right along. I think we have more callers, Miss Twitty.
Okay, it looks like we have another caller. Welcome to Count on Us.
Hello.
Hi.
Hi.
What's your name and what school are you calling from?
My name is Kumba, and my school is Melwood Elementary.
Okay, Kumba from Melwood. Kumba, what are you calling today?
I already called.
Okay. So you're calling us again to do a challenge?
Yeah, the 24 challenge.
Okay, so we have the 24 challenge cards up. Kumba, what card are you going to try today?
Card A.
Card A. So you have the numbers 8874.
Yes.
Okay. So we're going to write those numbers, 8874. Okay, Kumba.
8 minus 7 equals 1.
Okay.
4 minus 1 equals 3.
Okay.
3 times 8 equals 24.
Nice job, Kumba!
Very good, Kumba.
Very nice job. Okay, so we're going to put your name back in the chest for our drawing at the end of the show, okay?
There it is.
Okay.
All right, good job, Kumba.
Thanks for calling. Okay, we have a lot of great callers today. Let's move on to our next caller. Hello, welcome to Count on Us.
Hello.
Hello, welcome. And what is your name?
Geraldine.
Hi, Geraldine. And what school are you calling from?
Leonard Woods.
Excellent. And what grade are you in?
5th.
Oh, 5th grade. Love 5th graders. How can we help you today?
I need to find the value of n. And it's in ratios. So it says 7 to n is equal to 49 to 7, and to find the value of n.
Like this? Is it like a fraction, or is it like a ratio like this?
Like that.
Okay.
Like how you're writing it right now.
Okay. All right. So, tell me what you know.
Well, I know that the outside numbers, the 2 sevens,
are
called the extremes, and the 49 and the n are called the means.
Okay. How are we going to figure this out? You want to figure out what n is, right?
Yeah.
Okay. So which part of this ratio is complete? Which part do we know for sure?
The extremes.
Well, we know this part over here, right? This is complete. There are 2 numbers over here.
Yeah.
Okay. And then this is the part that has something missing. We want to figure out what that n is, right?
Yes.
Okay. Well, what I like to do is ratios we want them to be the same. So we want to figure out the relationship between these 2 numbers and give it the same relationship over here. Does that make sense?
Yes.
Okay. So can you figure out the relationship between 49 and 7?
7 times 7 is 49.
Okay, so if I go backwards, 7 times 7 is 49. Good thinking. Okay? So how can I apply that to this side? Do the same thing over here. What times 7 will give me 7?
What? Oh, 1.
1. Let's see if that'll make sense. 7 is to 1 as 49 is to 7. That would make sense to me. Okay? Does that make sense to you?
Yeah, it's because my teacher taught me a different way.
Okay. What way did she teach you?
It's a he. And he taught me that the 2 7s on the outside, you multiply them, so then that equals 49. So then 49 times n would equal 49 too. So, oh yeah, so now it would equal 1. Because 49 times 1 would equal 49, 7 times 7 is 40.
Okay, so it's still 1 for the n. Okay, very good. Thanks for calling in, Geraldine.
And we're going to put your name in our treasure chest, okay?
Okay.
Okay, we're going to go right to the next caller. Hello, welcome to Count on Us.
Hello?
Hello, welcome to Count on Us. What's your name?
Abigail?
Hi, Abigail. What school are you calling from?
Ridgecrest?
Ridgecrest. How can we help you today?
Oh, this is for the challenge question.
Okay, you're ready for a challenge question.
Which one?
D.
D.
Ooh,
okay. So you have the numbers 4, 4, 9, and 3?
Yes.
Okay, let's see if you're ready. Whenever you're ready.
4 times 4 equals 16.
Okay.
Times 9 equals 144.
Okay.
144 times 3 equals 432.
Okay, you're out of numbers here.
So Abigail, remember you're trying to get the number 24.
Oh.
And you can use all the operations, addition, subtraction, multiplication, and division. So you don't necessarily have to multiply all the numbers together. Okay?
Okay, so try again and call us back within about 14 minutes, okay?
Yeah, I bet you can figure it out, okay?
Okay.
All right, thanks for calling.
Bye.
Bye.
Okay, it sounds like we're ready for our next caller. Welcome to Count on Us.
Hello?
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 Hi, welcome to Count on Us. What is your name?
Roderick Williams.
Hi, Roderick. Did you call in earlier today?
Yeah.
Okay, so Roderick, do you have another problem for us, or are you going to try a challenge?
I have another problem.
Okay, what's your problem?
My problem is an airplane descends at a rate of 500 feet per minute. Write and evaluate an expression to show how far the plane will descend in 6 minutes.
Okay, so every minute they're going to descend 500 feet. That's what the problem says?
Yeah.
Okay. And so you want to get to 6 minutes?
Mm-hmm.
Okay. All right. Have you ever tried to make a chart?
No.
I like to make a table. I like to make a
I
chart.
think that's a good suggestion.
So you're telling me that every time there's 1 minute, the plane descends 500 feet.
Yes.
Okay. So I like to use a little T chart here. It's really easy to make. You just make like a letter T. Okay. And then I can kind of keep everything organized. And I bet you can start to see a pattern. So if after 2 minutes, where would the plane be?
The plane will be at 1,000. Oh, wait, no.
You're right.
Yeah, 1,000 feet.
Right. If after 1 minute's 500, so if I have 2 of those, it would be 1,000. Very good. What about 3 minutes?
1,500.
Okay, good. You're catching on. See, that's why I like the table or the chart, because it makes a pattern very quickly. Oh, I'm running out of space. I didn't really space it out. I hope you write neater than I do, okay? 4 minutes.
4 minutes, 2,000.
All right, I like this problem. What about 5 minutes?
2,500.
Excellent. What about 6 minutes?
3,000.
Right. Very good. Now, you could have multiplied and gotten the same answer. Okay? You could have multiplied 500 times 6, and we could have gotten 3,000 as well. But sometimes I like to see a pattern with the chart, and I can go through it very quickly. Okay? Was that helpful?
Huh?
Was that helpful for you?
Yes.
Wonderful.
Okay, so Roderick, what is your expression?
My expression.
Didn't you say the problem said to create an expression to show how far it would fall after?
Yeah, it said write and evaluate an expression.
Okay, so what would the expression?
I don't know.
Do you know what an expression is?
No, not really.
Okay. So an expression is just a way to show something. It's like an expression on your face, like a smile. Okay? It's a way to show something mathematically. All right? So if we look at the numbers here, we can make an expression about how the plane is falling. So Miss Twitty, what do you think? I'm not quite sure what the teacher wants. Do they want feet per minute? What kind of expression could we make?
I would suggest maybe the 500 times 6.
Could be 500 times 6. That's an expression. Okay, I showed you the table, but I guess if they really want to know the expression or a way to get it, you would use multiply, because every minute is 500 feet. So a way to show that is 500 feet per minute. So it's 500 times 6. That would be your expression.
Okay, Roderick?
Okay.
All right, thank you for calling us back. We're going to enter your name in the treasure chest another time, okay?
Okay.
All right, we're going to move on to the next caller because we're running out of time.
Hello, welcome to Count on Us.
Yes.
Well, hello. How are you?
Good.
Great. And what is your name?
Ryan.
Hi. Oh, Ryan. Are you calling back, Ryan?
Yes.
Excellent.
Okay.
What school are you calling from again?
Melwood.
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 Okay. And what are you working on this time?
I'm ready to do the challenge.
Oh,
okay.
Ryan is ready for the challenge. Okay, Ryan, what card are you going to work on?
I'm going to work on A.
A. So you have the numbers 8, 8, 4, 7. Ryan, do you have those numbers?
Yes.
Okay.
All right. Anytime you're ready.
Okay, Ryan, what's the first step?
You have to...
Okay, Ryan, have you already worked the problem out?
Huh?
Have you already solved the problem?
Yeah.
Okay, so what did you do first?
I did 5 and...
Well, 5 isn't one of your numbers. I want you to use these 4 numbers to make 24.
Oh, okay.
Okay, you can call us back. We'd love for you to work on it.
No, it's okay. Tell me the numbers again, please.
Okay, so your numbers are 8, 8, 4, 7.
So make sure you take those 4 numbers. You can add them, subtract them, multiply them, or divide them, or any of the combinations, okay?
Okay.
All right. Work on that, see what you can do.
Okay.
All right, thank you, Ryan. We're going to move on to our next caller, though. And then while Ryan's working on that, he can call us back as soon as he's finished figuring out the problem. Hello. Who else is out there today working on their homework?
Hello?
Hello.
It's Geraldine back with a challenge.
All right, Geraldine.
Geraldine is back with the challenge. Okay, Geraldine. Which card are you going to solve today?
It's D, 9344.
Oh, 9344.
That's
okay.
D, yes. Okay, 9344. Okay, Geraldine, are you ready?
Yes.
Okay, what was the first step?
9 divided by 3 equals 3.
Okay.
And 4 plus 4 equals 8.
Okay.
Whoops.
8 times 3 is 24.
Good job!
Excellent, Geraldine.
Woo! Very nice job, Geraldine.
That was a hard one. We're very proud of you. Excellent. Thanks for calling in, Geraldine. We put your name again in the treasure chest, and you might be our winner for our show.
Okay, so go ahead and try one of the other ones. You have a few minutes before the show's over, okay?
Okay.
All right, good job, Geraldine.
Okay, and we're moving on to our next caller. Hello, welcome to Count on Us.
Hello?
Hello, what is your name?
Naomi.
Hi, Naomi. And what school are you calling from?
Templeton.
Templeton. Excellent. And what grade are you in?
3rd.
3rd grade. Love those 3rd graders. And how can we help you today?
With my multiplication problem.
Multiplication. Okay. And what is troubling you today? What problem are you working on?
12 times 12.
Ooh, 12 times 12. Wow. That's a tricky one, Miss Twitty.
Do you have any methods that you've been using in your class?
No.
Okay, so we're going to multiply 12 times 12. Naomi, what do you think we should do to start?
Well, I know in 3rd grade you don't usually do double-digit multiplication. So is this just a math fact that you're trying to figure out?
Yes.
Okay.
Oh.
Well, you know that 12 times 12 means 12 groups of 12, doesn't it?
Yeah.
It does. So what I could do is I could go ahead and I could draw 12 groups and I could draw 12 things inside each of those groups. That would take me a long time. Right, Naomi?
Yeah.
Okay. Well, I'm sure that your teacher started to talk to you about a different method. What I can do is I can decompose some of these numbers. And 12 times 12 is the same as 12 times 10 plus 12 times 2. Because 10 plus 2 is 12. And I bet you know both of these facts. What's 12 times 2?
24.
Good. You know that one. And what's 12 times 10?
120.
Oh, you know the easy ones. This is a great method because if you know your easier facts, if you just break apart or decompose that other number into 2 different facts, then what you can do is take those answers and put them back together like a puzzle and get the answer to your original question. So if I take 120 and 24 and I add them back together, what's 4 plus 0?
4.
What's 2 plus 2?
4.
What's 1 plus nothing?
2. 1.
1. So our final answer is 144. Does that make sense?
Yes.
So sometimes with those hard facts, all you have to do is break them apart into the 2 smaller facts that you know. It can be really helpful. Thanks for calling, Naomi.
We're going to add your name to our treasure chest, and we're going to keep going because we're almost out of time. So hello, welcome to Count on Us.
Hello.
Hi, what's your name and what school are you calling from?
Abigail.
Okay, hi, Abigail.
Elementary.
Oh, you want to try the 24 challenge again, huh?
Yes.
Okay, so what card?
It was D.
B as in boy or D as in dog?
Dog.
Okay, so 4493?
Yes.
Okay, Abigail, go for it.
4 times 3 equals 12.
4 times 3 equals 12.
9 times 4 equals 36.
9 times 4 equals 36.
36 minus 12 equals 24.
Good job!
Excellent.
All right, Abigail, we're going to add your name to our treasure chest, and we're going to move on to one more caller. Welcome to Count on Us. Hello?
Hi.
Hi, welcome to Count on Us.
Hello.
Hello, who is this?
Brianni.
Brianni, okay. Welcome to the show. What school?
Scotchtown.
Okay, and how can we help you today?
I have a question on the distributive property.
Okay, and what question were you working on?
It says, write the distributive property to state the multiplication that multiplication distributes over subtraction.
Distributes over subtraction.
Write the distributive property that distributes multiplication over
subtraction.
Over subtraction. Did they give you a specific example?
No. Well, the question before it has...
Yeah, it's really kind of hard to for us to help you if you don't have a specific example, and our time is getting really short, and I hate to not answer your question, but if you could get us some more information on that, and we would love to hear from